Well, we're going to go ahead and get started with another episode in this series of IT modernization presentations here at AWS Summit. And thank you, each and every one of you, for participating, whether you're in the audience or up here on the stage. I think this discourse, this dialogue is important as all of us take a look at this journey towards greater efficiency. We're going to be talking about how the federal government in particular has, in several instances, continuing the theme that we've been hearing all day, moving towards greater efficiency, greater productivity with data and the use of data through cloud and hybrid cloud technologies. So I'm looking forward to it. We're going to hear from our guests here in a moment, and we want to engage with you following their presentations or their discourse, to engage with you and ask questions of them, because I think this is going to be an extraordinary panel for you to learn from, and we want to learn from you as well. So to get things started, I'm just going to kind of work from left to right here, and on the panel with me, Rebecca Decow, and she is a research scientist at the Smithsonian Institute, the Office of the CIO. She has a BS in biology from Cornell, and a PhD in evolutionary biology from the University of Chicago, not far from where I went to school, so always happy to have a fellow Chicagoan on the panel. She and Paul Franson make up the newly formed data science team at the Smithsonian, and they're working with Smithsonian scientists to conduct biodiversity research, including genomics, informatics, and deep learning. And I want to begin, well, after each introduction, we're just going to ask the participants here to talk a little bit about what brought them here and where their journey to the cloud and to data IT modernization has taken with it. So Rebecca, a little on your journey to date and what has been your experience in the cloud?
Sure, so the Smithsonian Institution, which I'm sure many of you know, is comprised of 19 museums, 9 research centers that are dispersed as far as Panama and Annapolis, Maryland, and also a zoo. And so the Smithsonian, the mission of the Smithsonian is the increase in diffusion of knowledge. We study everything from, every organism in the tree of life. Pretty much there's a Smithsonian scientist who has some research question in that area. And so as genomics is a good example, as genomics has been on the rise, researchers have increasingly large data sets that the research computing part of the Smithsonian has taken on the task of managing those data and also enabling researchers to analyze those data. Most of our researchers are not trained bioinformaticians, they're subject matter specialists, and so what we're doing in the Office of the CIO is enabling that research, both with local compute resources and also now in the cloud.
And we'll go into more on that. Our next speaker, panelist, is Niels Goldstein, and he is one of the directors within CGI Federal's Emerging Technology Practice Product Development Team. And I'm going to say, just by way of introduction, CGI Federal is a big member of my prime contractors group at the NITAC under NIH, and we're a GWAC contract, and CGI Federal is one of those participating prime contractors, which has done such extraordinary work on that front. Mr. Goldstein is responsible for cloud management enhancements, working with CGI's Unified 360 platform, and that calls for an incorporation of DevOps, containerization, such as Docker application, performance management, and integration of other new technologies into the platform. You have a long history of other experiences as well. Neil, tell us about your journey professionally and with the government as their journey continues.
Yes, thank you. So I've been in IT for about 30 years. I started off doing data warehouse business intelligence. And after a number of years of doing that, I became a database administrator and a system admin and realized that IT really doesn't use the tools that it provides to the business. And so I really started to focus on how to use data analytics to drive successful IT outcomes. And one of those was the development of cloud resources and understanding the intersection of finance, the service level commitment, the ability to deliver services in a redundant fashion across a variety of medium, and to take advantage of collecting data and providing that to the business so they understand what works and what doesn't.
Terrific. A long journey, no doubt, but a wealth of experience. Our next panelist is a gentleman I had a chance to interview for our webcast. This program will also be on the NITAC Now webcast, but John Galvin, you are the lead for the worldwide public sector practice at Intel. Welcome to this panel. Give us a little history on what brought you here to your current role.
Yeah, well, good afternoon, everyone. Before I talk about myself, I want to give a little bit of context of Intel and what we do within this space. You probably know us as a microprocessor company, but we also do quite a bit of work with government agencies at a national level, even sometimes down to a city level, where we can act as a trusted advisor and talk about certainly what's coming in terms of roadmap and where we see the industry going and technology going. But I think one of the values that we bring to those discussions is that we participate in those discussions around the world. And so we can come in and share what we've seen others doing and really try to understand the problem and how to bring a solution together working with our ecosystem partners, since we work with pretty much all players within the industry. And then just a little bit of background on me. I've been at Intel for 22 years. Over the past 5 to 6 years, focused on education, and then last year took on responsibility for all public sector globally.
Terrific. That brings us to our last, but certainly not least, the panelist to my far left, your right, a gentleman who I've had a chance in working very closely with over the past few months, one who has spent a lot of his time working to bring the federal government, particularly Department of Interior and the USGS, bring them up to speed with the migration towards the cloud. I'll let him talk about that. Mr. Harry House.
Yeah, thanks. About 2.5 years ago, I was charged by a fellow that is now the acting director of the USGS to oversee an effort to establish a presence in the public cloud environment for our entire bureau. Advantage for the USGS is we didn't have a whole lot of folks going into the cloud prior to that, so we've been able to come into this from an enterprise perspective straight off the bat. 4 of our team here, we're going up to the deputy CIO, including operational line supervisors are sitting right here, our project manager.
Welcome to the panel.
Yeah,
Thank you
right
for
here.
joining us.
I guess I'm pointing that out. We have tremendous support all the way up to the director in our bureau to do this effort. And I won't go into details right now, but I say that journey for the last 2.5 years has been an agile one, the lessons learned, keep adjusting, see what's resonating, see what isn't, and learn from that and adjust and keep going forward.
Thank you. I appreciate that. We're going to hear more on the projects themselves. And to start this, I thought it would be good, John, to talk a little bit about what we discussed yesterday, and that is this move towards digitization in the public sector, and particularly the federal government, and what is going on here with our nation and the federal government moving towards modernization. I think most of the folks that are involved in the federal government know about the current MGT bill, but that's just one of the factors. Funding is important, but so is technology and the use of it, and we're so happy so many of you are here joining us in this effort. John, tell us about the move towards digitization and the various federal aspects that it pertains to.
Yeah, sure. As we talked a little bit yesterday, all of our conversations now are around how to move digital and how quickly it can happen. The transformation is happening at a speed, I think, faster than we anticipated. We've been having these conversations for a long time. But now it really is, how can we do it and how can we do it now? To your point, there's been a lot of experimentation that's happened, but now it's really moving beyond experimentation. It's really, I would say, how quickly can we get there, but also what are the new things that we can do? So now with the capabilities that are available, are there additional insights that we're going to be able to gain? Are there additional data streams that potentially are now also considered? And it's just also I would say, overall sharing of data.
I want to feed off of that a little bit and talk to Rebecca about your discipline, which if you look at genomics, and I know you're everything but human genomics, and that's an amazing kind of field of study because so much of the work has gone in, particularly within the health agencies around the advantages of genomics, but you are tackling that for kind of the rest of the tree of life, as you say. Tell us about the dimensions of data, and what are you hoping to accomplish from an analytics perspective? I know you're working with Intel and Amazon to exploit the data, so tell us about that journey and what you're trying to do.
Sure. So at the Smithsonian, we think genomics and also other kinds of digitization can really raise the level of science and open new scientific questions. So most of the software tools used in genomics were developed around the human genome, but we're trying to do everything else, and with maybe not the budget that the human genome gets because of all the health impacts. So what we're doing, we're also learning about genomes where we really don't know much about the biology. So we are developing our own software as well as using existing software. The cloud has been really great for that because it allows us to really experiment with new things, to be really flexible. We can send out a job onto thousands of cores and then bring it back in a really cost-effective manner, where we don't have to invest necessarily in a brand new kind of hardware to do these new kind of computations. We can explore things and test them out in the cloud. And then we can also kind of containerize that and send it to collaborators across the world. Most Smithsonian researchers are working on big teams of people all over the place, and they'd like to share their data and to share their workflows. And I think cloud allows us to start doing that more effectively.
There's a degree of agility that your approach is
Absolutely,
creating.
absolutely. Yeah.
Terrific. I want to go back to Harry, who has similar large data demands at USGS. Harry, tell us about your project, tell us about your history, and I want to say Harry's another Midwestern guy up here from Wisconsin originally, so tell us about your project and why it matters and what other folks can learn from the challenges that you have faced.
I thought you were going to ask me about the Packer draft selections this year.
No, because I'm a Minnesota Viking fan,
so
and
sorry.
you know how that goes.
So sorry about Bridgewater. All right, well, that's a big question. I'm not going to go in great detail. I will say, by the way, after this session, if anyone would like to talk to us more in depth about this journey, this group here, I'm guessing, will be available to talk to you as well as myself, and they present different perspectives, so that I'm guessing they'll be willing to hang out a little bit. Again, we are doing this, any cloud-related technology or services that we might want to use comes under the auspices of this, if you want to call it a project. We consider it a program, and we consider this probably one of the most fundamental programs happening right now in the USGS, because at the end of the day, we're a data science organization with emphasis on data. The data's got to go somewhere. It's gone internally for years. It's quite obvious in the future it's more and more going to go to the cloud. So if you think about that, the very viability of our mission is resting on this group, as far as I'm concerned, and the partners that work with us. So we're touching on something as you might say as mundane as offsite backup to the cloud, right? We're also looking at something that's as forward-thinking as data coming off of sensors, how to pull it into a cloud for rapid assimilation or examination for an alert. That's not science, right? But that's value added for the data stream. We're not unaware that you could take that same stream and drop it into a persistence data storage, large systems, and hit it with analytics or do data mining. That's sort of the future in some ways of science, the big data type thing. But we can't do it all at once, certainly not with our budget, so we have to do it in pieces, and what we think is most strategic today, and just keep building capability. So that's sort of how we're approaching it. And I mean, I could talk for 5 hours about how we're approaching this and what we've learned to do or not do, but I think that's enough for me for right now.
Some folks in the audience may ask you to do that, but did you, along this journey, I appreciate your offer to help others because I think that's so important for the community. Did you receive any kind of help? Did you reach out for help along the way? Did anyone serve that purpose for you?
Yeah, we've had tons of help. I came to Amazon reInvent, I think 4 or 5 years ago, and I asked questions of tons and tons of people who had been to the puppet show and gave me all kinds of advice, okay? I've been involved in cloud technology seminars in California, stuff like 8 or 10 years ago. Myself and our team do a lot of work to keep up with things. We have several contractors that work with us that give us strategic advice as well as operational capabilities. I think the lesson there really is if you're going to get involved in this, you have to, as management, have to be aware of the services that are coming out there, the capabilities that are coming out there, what other people are doing. That's, I would say, is number one. And I would also say there is absolutely no substitute for your technical staff actually getting into the cloud and working there. They can whiteboard it and watch videos all day long, but until they get in there, they're not going to completely understand what it means to work in that environment.
Thank you. Niels, we're talking about challenges along this journey. With your wealth of experience, particularly in the federal government, what are some of the major pitfalls folks can experience? You've worked with many agencies, many departments. Where are those folks going to help, and how can they get help, and what are some of the circumstances which they may find themselves in?
Yeah, a big problem that a lot of agencies have when they're trying to go to the cloud is there's some vested interest and some inertia that are used to traditional ways of doing things. And sometimes when you start looking at data-driven analytics for making decisions, it doesn't necessarily always match up with people's intuition or their past experiences. And when you start moving into the cloud, sometimes it takes a completely different cultural view of everything, from your development methodology to your management methodology. A lot of the techniques that were learned in the automotive industry, like lean management, applies to agile software development. And to really support a lot of that, you've got to have data behind the scenes. And that data that can provide you with the metrics and measurements as a executive who's managing cloud activities can provide you with a lot of ammunition and a lot of information and insight into what the path is that you should follow. And so if you follow that, it can help you overcome some of that inertia by giving people the evidence that they need to see that this is a more cost-effective way. We can't compete with the economies of scale that organizations like AWS can provide. We can change our processes and we can show better customer-focused outcomes. And that's really a big thing, is changing IT from being, this kind of closed organization that does things because they're keeping the lights on, and 90% of legacy IT is keeping the lights on. They don't really have time and energy, but providing with that metrics and that data can help them see that there's a path forward and there's a way to overcome those challenges, and especially when you have groups that have been doing things for a long time. And when you're dealing with large government agencies that have acquired things via contract venue over many different years from many different vendors, you wind up with this kind of mishmash of things, and understanding what to tackle first. If you don't have the data that shows you usage of the information or security risks or any of that other stuff, it's hard to make decisions, and just trying to do it anecdotally doesn't always work. So having that data behind the scenes really helps you overcome those challenges.
John, is the business case the hardest thing for someone trying to say, can we do it better?
I think the business case certainly is do it better, do it more cost effectively. There's certainly a security discussion that comes into play. Can a cloud provider like AWS provide better or higher level of security than you'd be able to provide in your own data center? I think the conversation also, though, is, and maybe to build off of that point, of you have some data today and you know how it's being used, but you don't necessarily have a sense of how all of the data is being used. As well as the value proposition of you now have all of the data coming together. And is that really going to provide new insights? And And we really try to have those future-looking conversations of almost the art of what is possible. Let's not be restrained by how it's being used today, but by breaking down some of the silos and this data now coming together under new usage models, what does that really make possible?
Let's just say the business case makes sense. Harry, you have talked to me on numerous occasions about the people it takes to get there, the technology expertise. How does an agency make sure they have that talent in-house?
I think it starts with what is your budget and what is your culture in your organization. We ourselves are big proponents of having a lot of government staff that's involved, either at the managerial or the operational level, complemented by enough contractors to provide some senior leadership in some cases or specific technical expertise, and to pass that down to our government staff. Now, different groups do things differently. That's just how we're doing it in the USGS. I've actually done things that way for 15 years before I got into this and built a data center, and I thought it was a successful model. Okay, but there's different ways you can do it. I will say, if you're going to talk about workforce in general, that's actually a compelling reason to go to cloud. Anyone here that's been in charge with hiring good, competent IT folks knows it's not an easy hire, it's not an easy retention, and frankly, from one perspective, the more you can outsource to a public cloud provider, so you don't have to have as many network engineers, as many DBAs, as many storage experts, and people to keep the lights on, and the air conditioning, and the power, and all that kind of thing. That just makes your job as a workforce manager that much easier, all right? So that's one reason to go to public cloud. And for the USGS, I can see our workforce matrix shifting more in the IT realm, more towards developers and less towards system administrators and so on. We'll still need some, but they'll be cloud-centric, so one sysadmin can support way more program than what we could in the past.
This conference has highlighted so many of the promising aspects of the future. You mentioned efficiency. Rebecca, as you look at the vision that you hold for research at the Smithsonian, and frankly, we look around the world and we see, the status quo or the current state of productivity is essentially flat, and you can see that reflected in all sorts of metrics. But the things that are being done in data, in analytics, artificial intelligence that we're seeing here at the conference, all of those technologies represent the next leap that we can make as a society towards the future. And tell me, Rebecca, about the future state that you see as a result of the research being done and the efficiencies that you're trying to tackle in your research efforts at the Smithsonian. What's that going to mean?
So for many of our scientists who are not exactly trained bioinformaticians, they would like to get into genomics. The cloud really allows us, so part of our collaboration with AWS and Intel is proposing this $10 1-hour genome annotation. And so genome annotation, once you have a genome put together by assembly, it's often not to the chromosome level. So the human genome, we know, where the chromosomes are, what genes are on what chromosomes. For most other organisms that have genomes, we don't quite have that amount of information for a variety of reasons. And so you're left with genomes in lots of pieces. The genome annotation pipeline has to happen on each of those pieces individually. And by doing it in the cloud, we can shoot off thousands. So you may have thousands of pieces in each genome. We can shoot out thousands of processes and bring it back together. And being able to tell a researcher, oh yes, you can do that annotation for $10 would be an amazing thing, something that they've previously spent months doing or found an outside collaborator to help them. So that's something I think that will really increase the efficiency of science and kind of accelerate the kinds of questions people can ask. We're also working on a project on some endangered species, it's conservation genomics projects. So there's an endangered, critically endangered South American bird, the red siskin, which has a whole project around it where we're sequencing the genome, and then we're developing markers to use for population management. So there's a captive breeding program at the Smithsonian Conservation Biology Institute where kind of in real time, we're able to genotype those captively bred birds and find out which ones should mate for the the best success of this new captive population. So there are kind of real implications to being able to do this work quickly.
Really is a comprehensive view in support of the concerns that we all face. So we appreciate the effort. Niels, I want to ask you about kind of a holistic view of the federal government in moving towards these new technologies and reaping the benefits of them from a productivity perspective. What is kind of your worldview on moving towards that new next step of the ladder in terms of how does government do it better, faster, cheaper, and provide real service, overcoming some of the impediments such as budgets and other things? How are we going to get there, and what is that going to mean?
Yeah, I think to Harry's point, the cloud and the changing nature of deploying and building services means that people get to spend more time using the systems and using the data rather than the process of managing and collecting and designing the infrastructure that's needed to gather that information. So the changing nature of the roles is that you can do more science with the people that you have, and they don't have to spend as much of their time doing things that are not part of their core mission. And then I think that this is really a sea change, and it's going to change for a lot of agencies the fact that you don't need legacy or traditional IT as much. Now you need a slightly different skill set, people that understand how to read and interpret the data, whether it be services management, right? You're going to have people that are cloud administrators. That's a little bit different role, managing the services for people than a systems administrator. You can build a systems administrator into a cloud administrator, but it's a slightly different skill set. It requires people to understand more about what the business requirements are and how to communicate with people who are using the systems, as opposed to, I need to have a talk with a peer down the hall about this component doesn't talk with that component. That's a changing nature. And I think that will help agencies shift some of their budget priorities to more toward their core mission, rather than spending it on ancillary or support activities that really aren't tremendously value added to their end goal. And I think that's a big sea change that's happening. For example, we're doing work with USAID. They can now spend more money on their mission and less on running their IT. And that is a change that's going to affect every agency, every government, all the way down to state and local. They're looking for new ways. They're people that used to manage these systems are now thinking of ways that they can increase the outreach to the citizens, to have citizens be more of a participant in government and contributing applications, almost like making a store and say, if you're a constituent and you want to contribute an application, you can do that. In Arizona, they did that with real estate and permitting. This contractor who was building houses had such a problem with the permitting process that they redesigned the permitting process and submitted the code to the government, who then incorporated it, and now they're using this customer's code. And it has streamlined the process from taking weeks to taking hours. So it changes your constituency, who can contribute to the efficiencies, and I think all of government will experience that at some point.
It's also a people issue, though, and we were talking earlier, this idea that yes, we can share, we can collaborate. Mm-hmm. John, any comments on what is the realm of possible in terms of federal government agencies working between themselves? We've talked about this, is sharing expertise, sharing real services across the web networks.
Yeah, absolutely. I mean, if I just reflect on some of the conversations that I've had here over the past couple of days, we were having conversations around IoT and collecting that data at the edge, and now how do you make that data available, not just for that single purpose, but potentially serving other purposes as well. Mm-hmm. And where as we were even having conversations around artificial intelligence and now what is possible there, I mean, you have to be able to link to some of those other data pools to be able to get that full benefit that you're looking for. I think what is interesting, and what we've heard a couple of times, again over the past couple of days, is that, just based on the number of people that are here, growing from 50 people 10 years ago to 10,000 people who registered this year, it's far more real. So everyone is now seeing what is possible, and I think they're already trying it. They have already experienced what the cloud enables for them. So now it's the conversations of what more can we do. And I think your example in Arizona is a great example. And we're seeing examples like that around the world. Part of that is the government's making data available publicly. And people can now build those applications and innovate, and they have access to big data, which a small entrepreneur innovator normally would not have access to. They wouldn't be able to collect those data streams to be able to build that data pool. So now I think the government is being open to how can citizens essentially take advantage of that data and be able to either provide new services through the government or in some cases provide them to supplement what the government's doing.
Harry, the worldview of what's possible, what kind of innovation is in store, particularly at USGS from your perspective?
Via the cloud, of course, right?
Sure.
Yeah. We've got all kinds of ideas. I would say one thing is at the core, what makes the USGS valuable? And I think at the core, one of the big ones is the data. We've got data that's gone back, records that have gone back a century or more. And the people, too. That's another one of our big, without the data, the people can't do much. But I would say, in my personal opinion, I'm an engineer. I'm not really actually an IT person. I'm not a scientist. All right. In my opinion, we have leveraged the data for the data itself. We've done that pretty well, but we could do it way, way better, okay? And I think one of the impediments has always been the IT infrastructure and how you distribute the data and those kind of things. And the cloud is presenting an opportunity for the first time in my 30-year career. It's right there in front of us. It's right there. So we can light up that data, okay, and put it out there. The second thing is, as I said, science is evolving to become multidisciplinary. It's becoming global. It's becoming integrated. And we do not have the physical infrastructure to support the kind of research we need to do to be relevant going forward into this century. We just don't. We don't have the budget. We don't have the personnel to manage it. The cloud is our only chance to do that. So that's the avenue for science. That's the vision there. That's the avenue for lighting up that data, right? And beyond that, as far as individual ideas we have, I could go into that for an hour. That's okay. I won't bore the crowd. But we've got all kinds of ideas. Our problem is not ideas. It's not having customers that want to participate. Our problem is being able to scale it and get it out there. The demand is there. We just have to do it.
Eloquently said. We have about 15 minutes left, and this has been a phenomenal panel. We have federal government, we have industry, we have system integrators. So I will open it up to the floor for questions from any of you who are on this journey or want some help or guidance from any of the team that we have up here on the stage. Simply raise your hand and we're happy to do it, or come after you, sir, in the white. Let me just bring you a microphone. We'd love to hear your comments on the presentation and ask questions.
Thank you so much for sharing exciting information and success stories. My question is, if we look at the legacy data domains, we have top 3 challenges. It's a diverse, heterogeneous data containers, lack of standards, and high rate of data redundancy. So when we plan to migrate to modern solution in AWS or in any cloud environment, how we plan to knock down these challenges?
Let me.
Who wants to go?
Who wants to go on that one? Harry?
Sure, I'll go. My answer to you today is different than it would have been 2.5 years ago, and that's an example of how our thinking has changed once we've engaged in this, despite all of our due diligence going into it 2.5 years ago. I think the answer to that, first of all, is you can be successful in many different approaches to how you do this as an organization. That's number one. Number two, it's going to be informed by your culture and your budget and maybe the operational silos of power. Okay, you have to be realistic about what's possible and what isn't. But I can speak to our particular environment, which is pretty budget and limited, and so on and so forth, though we do have some pretty good central sponsorship. I would say if we had to do it again, rather than say, bring people in into a custom environment so they can come in and bring their application in, whether they refactored or not, or lift and shift it, we should have done less of that and more of, here's a managed service that a bunch of folks can use. Like, here's a LAMP stack, we're gonna run that, and anyone that wants to drop something into that, they can do it. Because we can manage it, we can secure it, and we can make that available and cost share that. That's an example. Or let's do offsite backup for everybody. Or let's do a high performance computing cluster capability for everybody. We should have done that right off the bat and avoided trying to bring in these ones at a time type folks. Now, the second thing on that is if you do come in and allow some folks to bring in, here's my big application. From our perspective, it'd be better if that group has a critical mass of skills that then when they come in, they can kind of, you can give them some policy and some guidance and some environment and they can come in and they got it. If you got someone that's a biologist part-time doing this with a spreadsheet or something, it's just very difficult to support. And the last thing I'll say, and let other people speak here, is I would really prefer that they can refactor that application so that it is cloud focused as it comes in instead of do the lift and shift. And the reason why, even though lift and shift is fast, it's very hard to support 100 different groups that are just lifted and shifted and come in for the operational support team in the cloud. So that would be my thoughts. And that means that group is better have a critical mass or have people that can learn how to do app refactorization as it comes in.
Niels, any comments for the Department of Labor?
A big part of any project that deals with multiple systems that came from different regimes, different purchases over different times, is really good controls on data analytics and your ability to analyze and understand the data that you have. A lot of modern tools, robotic testing, and so forth, can be applied. Even some of the artificial intelligence things like doing pattern recognition and pattern matching can take a look at some of that older data and figure out what is meaningful, what is redundant, what should be saved, and what shouldn't. And I think that those tools are coming and will make that process a lot easier.
We have a question in the front row. Your name and who you're with.
Claire Walden, I'm with LMI. My question is, how are you measuring success? Is it cost recovery, productivity? What kind of measures are you using against the actual cost of moving to the cloud?
Rebecca, any observations on the metrics to validate your move towards the cloud and the work that you're doing?
Yeah, so within the Office of the CIO, our research computing group, we reach out to researchers and they reach out to us often and tell us what they need. And so we interface with them quite often and offer trainings and also get lots of feedback in terms of what's not working for them and or maybe they've heard their colleague somewhere else, they've tried a new piece of software or a new system, and we try to test those things and integrate them into what we're doing. We're still in the early stages of this, but really just feedback from Smithsonian has around 700 or so researchers, feedback from them, they tell us what they need and we try to provide it.
John, any comments on the business metrics that validate these modernization efforts?
Yeah, sure. I would say each of the projects are different. And so that becomes part of the early conversation that we have of first of all, what is the problem that they're trying to solve? But then also clearly defining the success metrics up front. And sometimes that is a long-term cost savings. Sometimes it's simply a budget issue and what budget is available to them at that time, or it can be a time to market. So I think it really varies.
Thank you, Claire. Other questions? Thank you so much for joining us. I really appreciate the enthusiasm here at AWS Summit. I think this is a fabulous opportunity for folks to get together to formally and informally network and help move IT modernization forward with other folks' experience. So for our panel, Harry, John, Niels, and Rebecca, I'm Todd Schwartzrock with NIH NITAC. We appreciate you joining us this afternoon. Feel free to come and ask us any questions you'd like in the balance of the time, but thank you for joining us, and we'll see you hopefully again next year at Summit. Thank you.